For 4.6a, we're going to be graphing rational expressions. So let's look at an overall example and then look at some others. So the first thing we're going to do is start with our parent graph. And our parent graph is f of x equals 1 over x. Just to kind of remind you, the parent graph is the graph without shifts, without a stretch. It's the most basic version of the graph. So no shifts, no stretch. That's the parent graph. So before we get started, we're going to start with a table. And here's our x values. And we're going to plug them in and see what we get. So if I plug in 1 here, I get 1 over 1, which equals 1. When I plug in 7, I get 1 over 7. That's not going to be that fun to graph, but we'll figure it out. If I plug in 1/5, that gives me 1 over 5. This is the same as 1 divided by 1 over 5. And when we're dividing with fractions, we keep the first flip, change to multiplication. So here I get 5. Let's do this one. Let's plug in -1. 1 over -1 is -1. Let's plug in -7. I get -1 over 7. And if I do 1 over -1 over 5, keep, change to multiplication, flip, I get -5. This is the only time we're going to make a table. We're just making the table right now to figure out the pattern, okay? So make a note to yourself. Only time making a table. And we're doing it to find patterns. So we don't have to make a table in the future. Okay, so let's go ahead and graph these points. I'm going to count 7 over in both directions. So I did 7 right, 7 left, 7 up, 7 down. Okay, I'm going to graph 1, 1. And then I have 7 and 1, 7. So 7's over here and 1, 7. I'm just going to graph really close to the x-axis. X is 1/5. So x is 1/5 is like right here, really close to 0. Y is 5. So 0 and up 1, 2, 3, 4, 5. Really close to right there. -1, 1, right there. -7, -1, 7. So again, all the way over to -7 and really close to the x-axis. -1/5, -5. So -1/5 is really close to the y-axis. -5 is right there. Okay, so let's kind of see what pattern's happening here. My first question is, can I plug in 0? Can I know what's happening at 0? If I plug in 0, I get 1 divided by 0. Here's another note. X equals 0. 1 over 0 is undefined. So 0 doesn't work. So what happens here is we're going to connect like this. And we're going to get really close to the x-axis and really close to the y-axis. And we're going to have, remember those asymptotes we've talked about before? We're going to have an asymptote at the x-axis and an asymptote at the y-axis because I can't plug in 0 for x, so I have one at the x-axis, and I actually can't equal 0, so I have one at the y-axis. So let's make notes to ourselves. Down here, we're going to make some notes, and we'll make them up here. to kind of see what our key things are about this graph. So every graph we've graphed has had a key point. Sometimes the point has had a specific names like the vertex. Other times we've just called it the most important point. So for us, our most important point is the 0, 0. And that's because that's where we know our asymptotes are. So let's make an arrow and say most important point and y, know our asymptote cross here. So that's what's important about our most important point. And this point is 0, 0. And if you want to draw an arrow there so that way you know what the most important point is, you can do that. Okay, so question 1 asks us to state the equation of the horizontal asymptote. So the horizontal one is this one. Horizontal lines are y equals, so the horizontal asymptote, y equals 0. Next, we're going to do the vertical asymptotes. Now, vertical asymptotes is an x equals graph. So let's look up here. Our vertical asymptote. So here we have our vertical asymptote. Oh, you can't see what I'm writing. There we go. Here we have our horizontal. That one is y equals 0. This one's x equals 0. So it's x equals going through 0. Where is the graph increasing? Now, when I'm increasing, is there anywhere, and I'm picturing we're climbing up a mountain. So I'm picturing kind of like something like that, or like that. We're looking left to right and going up. If I look left to right, this is sliding down, sliding down. So we're not increasing anywhere. That's increasing. And then decreasing, is there anywhere I think that we're sliding down? So like that, or like that. And actually, this whole graph, if I'm looking left to right, here I'm going down, here I'm going down. So we're going to say from, let's see, this is going in that direction, so negative infinity to, we're going to stop at 0, because we're not defined at 0. Pick back up at 0 and go to infinity. I'm going to write this in orange. To 0, because we're not defined there. And then we have to write the other one. We start at 0 and we go to infinity. Again, let's talk through that. Okay, so let's do this piece we're decreasing. That's going to our negative infinity. So we're going negative infinity to, and this, what x value is this hugging? This is hugging 0. What x value is this hugging at 0? And it's going to infinity. So state the interval where the graph is less than 0. So this piece has us looking at our y's. When is our y less than 0? So that means below x axis. And when are we greater than 0? So this is when y is greater than 0, so we're above x axis. So let's look. When am I below? I'm below from negative infinity to 0. When am I above? Well, from 0 to infinity. All right, domain and range. Our domain, let's go ahead and look back up at the graph. We have two pieces, so we have to write both of them. Here I'm at negative infinity, and what do I get to? I get to 0, but I don't equal there. So that's the first piece. And then what's the second piece? The second piece starts at 0 and goes to infinity. And then for the range, let's look at this again. Our range, bottom to top. Bottom, we're going to negative infinity. Do I stop somewhere? I don't equal at 0, so we stop at 0. We start at 0 again and go to infinity. So let's look at the range again, just to kind of clear that up if there's any questions. What's our lowest value? It's going down, so we're going to negative infinity. But notice if I'm looking up, I don't cross this 0, so we have to stop at 0. And I pick back up at 0 and go to, this is going up to infinity. And this number will always be where your horizontal and vertical asymptotes are. Let's look at number 8. Number 8 asks us to use the definition of y-intercept to demonstrate why the y-intercept does not exist. And notice, I want us to note here that this is a case-by-case thing. This is only for this parent function. So the definition of y-intercept is to make x equal 0. So y equals 1 over 0. I made x 0. I can't divide by 0, so this is undefined. So there's no y-intercept. Let's go ahead and look at number 9. Use the definition of the x-intercept. We're going to make y equal 0 to demonstrate why this doesn't exist. Okay, so let's make y 0. 0 equals 1 over x. Multiply both sides by x. X times 0 equals 0. X times 1 equals 1. Is this true? No, so there's no solution. So we have no x-intercept. All right, I know that was a lot. So now, just like all the other equations, we're going to adjust the equation to move it around. Let's go ahead and move on to that. We're going to use these key ideas. So key ideas, most important point, 0, 0. Vertical asymptote and horizontal. And that's what we're going to be shifting around. Okay, so now we're going to add in our shifts. So let's go ahead and we're going to think of this as y equals a, because we might have a number other than 1 on top, over x minus h plus k. And just to kind of review, a is our stretch, h is our right-left shift, and then k is our up-down shift. Let's look at example 1. We have y equals 1 over x minus 3. Since a is 1, there's no stretch. So x minus 3, this is opposite. So this tells us we're moving right 3. Now, when I'm thinking of moving right 3, I'm thinking of my asymptote. So we know that my horizontal asymptote is right here. Is that going to move right and left? Not really. We also have our vertical asymptote, but that is going to move right 3. So when we move, we're shifting the asymptote. So our most important point now is 3, 0, because we shifted right 3, we didn't shift up and down. And that important point represents how we're shifting. We went right 3, 0, up or down. So what asymptote moved? The vertical. This graph still does not have a blank intercept, but it does have a blank. Okay, so let's look at what x and y intercepts. Since I have an asymptote here, I'm never going to have y equal or x equals x on here. So we don't have an x-intercept. Since there's an asymptote there, we're never going to cross the x-axis. But since this asymptote moves, we can have a y-intercept. Let's go ahead and find it. How do we find a y-intercept? Make x equal to 0. Y equals 1 over 0 minus 3, 1 over negative 3. So that point is 0, comma, negative 1 over 3. Find it and label it on the graph. 0, negative 1 over 3. Looks like it's about right there. All right, so the other points we have to find, if we look at our example 1, are these points right here. If we look back at this graph, we see once we have the asymptotes, other important points are these two key points. And where are they? Well, they're 1 over, 1 up. And that's because we have a 1 on top. And then 1 to the left, 1 down. So let's do those. We have a 1 on top. So we're going to have a point 1 to the right, 1 up. And then we have a point 1 to the left, 1 down. And then we can just hug the curve. Make sure you go through that y-intercept. Like such. Let's go ahead and read through the question. State the equations of the horizontal and vertical asymptotes. Well, our horizontal one didn't move, so that's still y equals 0. Our horizontal one shifted right 3, so that's going to be x equals, it looks like it's going through 3. Next question, state the interval on which the graph is less than 0. This means when we're below the x-axis. So when is the graph below the x-axis? Well, from negative infinity to, what is this right here? 3. 3 is where we become then above the x-axis. When are we greater than 0? So when are we above the x-axis? Well, let's see. When are we up here? Well, it starts at, see, this is where we start being above the x-axis. We start at 3, x equals 3, to infinity. For example 2, we're going to consider h of x equals f of g of x. So this is when I'm going to plug g into f. So we're going to take g and put it into f. So h of x equals 1 over, instead of x, instead of that box, we're going to write x plus 4, and then I have minus 5. Let's think about how we're shifting. This plus 4 tells us we're going to go left 4. This minus 5 says we're going to go down 5. So let's go ahead and go to the graph. If I'm thinking left 4, I have my vertical asymptote here. So it's going to go left 1, 2, 3, 4. And that's up equals negative 4. If I'm going down 5, that's my horizontal asymptote. That's going down 1, 2, 3, 4, 5. And so that's at y equals negative 5. And from there, do we have a stretch? There's a 1 there, so our point is up, right 1, up 1, left 1, down 1. And so I'm going to curve up and hug, and curve down and hug. Same thing here, curve up and hug, curve down and hug. And it looks like we do have an x-intercept and a y-intercept, so we're going to have to find those. So let's go ahead and answer these questions. Our horizontal asymptote, well, we already know that's y equals negative 5. Our vertical asymptote, that one's right here. We know that one's x equals negative 4. Does the graph have a y-intercept? Yes. So find it. How do we find it? We make x equal to 0. So y equals 1 over 0 plus 4 minus 5, which is 0.25 minus 5, which is negative 4.75. Let's go ahead and plot that on here. That's going to be about negative 4.75 there. So our y-intercept's like right there. Do we have an x-intercept? Well, let's look. Yes, we do cross the x-axis. So we're going to make y equal to 0. All right. So to find this, let's go ahead and add 5 over. So plus 5 plus 5 Think of this as 5 over 1. And then we cross multiply. So I get 5 times x plus 4 equals 1. Because 1 times 1 is 1. When I distribute, I get 5x plus 20 equals 1. We're going to subtract 20. And then to another little arrow over. Sorry, I keep running out of room. Divide by 5. And in the calculator, this comes out to be negative 3.8. So that's negative 3.8 comma 0. And then the one up here, 0 comma negative 4.75. All right, so let's look at these questions. Where are we increasing? So that's, am I climbing up a mountain? This piece, blue piece is going down, this piece is going down, so we're not increasing. Where am I decreasing? Well, they're all decreasing. So we're going from x is negative infinity. Where do I stop at? I stop at negative 4. And then this picks back up at negative 4 and goes to infinity. Less than 0, where am I? Below the x-axis. Below the so that's negative infinity to negative 4. And then we have just this little here that's above. So we're trying to look at this piece. So that's negative infinity to negative 4. And then from this ends up being my x-intercept. What was my x-intercept? Negative 3.8. 2, and I continue to be below for infinity. All right, so now when am I greater than 0? Well, I start being greater than 0 at negative 4, and I stop at the x-intercept. So for both of these, we had to use the x-intercept. That was this negative 3.8. Our domain, negative infinity. We're looking left, right, negative infinity. We stop at negative 4. We pick back up at negative 4 and go to positive infinity. This number right here, notice this is my vertical asymptote. Range. We're going from negative infinity, and we take a pause at the horizontal asymptote of negative 5. Pick back up at the horizontal asymptote. I should close my parentheses yet. And I go to infinity. Notice horizontal asymptote.